Good morning, one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 for 5th semester student, Module 1, Lecture Series 8. Today our discussion is on undisturbed soil sample, disturbed soil sample, representative soil sample. Last class we are discussing about samplers and now we are discussing about sample. The soil which is collected from that sampler is called as a sample. Okay, so undisturbed soil sample, it may be defined as those in which the material has been subjected to a minimum disturbance is called as a undisturbed sample. For example, tube sampler or chunk sampler. Disturbed soil sample means the natural state of soil gets modified partially or fully during sampling. Even moisture content also not possible to protect it, then it is called as a disturbed soil sample. Example, open pit collection and trenches by using thick wall samplers. A non-representative sample. These samplers consisted of mixture of materials from various soil or rock strata or samples from which some mineral constituents has been lost is called as a non-representative samples. Agar or wash boring is the best example. Representative sample means the samples containing all the mineral constituents of the soil, but the structure of the soil may be significantly disturbed. Then it is called as a representative sample. Agar and core catcher method. If you collect the sample, then it is called as a representative soil sample. So sample disturbance depending on three things. So from last class and this class we are continuously discussing about the samples, thick wall sample, thin wall samplers. So undisturbed sample, disturbed sample, how it varies? It depends on three criteria. Number one, cutting edge. Number two, inside wall friction. Number three, non-return wall. So cutting edge. The cutting edge means it is the end of the core which cuts the soil is called cutting edge. So the cutting edge is the dimension of the cutting edge governs the area ratio, inside clearance, outside clearance. So what is meant by area ratio? So the area ratio is nothing but if you take this as a sample tube and this is your cutting edge or driven shoe. If you take the outer diameter of the driven shoe as D2, inner diameter of the driven shoe as D1, D2 square minus D1 square divided by D1 square into 100. If you do it, you will get area ratio. So similarly, the sampler tube inner diameter is D3, sampler tube outer diameter is D4, and if you calculate inner diameter and outer diameter, D3 minus D1 divided by D1 into 100. If you do it, inside clearance you will get it. If it is 0.5 to 3%, then whatever sample you collect, that sample structure is not disturbed, then it is called undisturbed sample. On the other hand, outside clearance is D2 minus D4 divided by D4 into 100. That is D2 minus D4 divided by D4 into 100. That is, it is a ratio between cutting edge and sampler tube if you calculate it. So then you will get outside clearance. If it is 0 to 2%, then whatever sample that we collected is undisturbed sample. So one more thing is there, that is in case of rock samples, we are using a word called a recovery ratio. So the recovery ratio means the length of soil retained in the tube divided by actual depth of penetration of sampler tube. Suppose we have 60 centimeter length of sampler tube. When we drive on the sampler tube in the stiff soil and only 50 centimeter sample we got it, remaining 10 centimeter sample we are unable to get it because of loose state or because of some pockets of air voids, etc. Then 50 by 60 into 100 if you do it, then you will get a ratio that is called a recovery ratio. If any sample, we want to say it as an UDS sample, if you get anywhere that recovery ratio is 96 to 98, that means almost 100%. If the 60 centimeter tube has used, means all the 60 centimeter length of the tube sample should be collected. Then this recovery ratio is 100. Small 1 or 2% is less, means it is recovery ratio is 98%. If you have a recovery ratio 98%, then we can say it is a satisfactory sample collection, and that is an undisturbed sample. In case of rock, we are using what is called as RQD. RQD stands for rock quality designation. That means we are using drilling bit and core catchers for collecting the cores. So when we start collecting the core from the ground, we won't get a full length of the core. We will get a bit length. Some cracks will be there because of faults, fissures, joints, etc. And any sample which is greater than 10 centimeter, we have to add it. So suppose we are moved a length of 1 meter core. In that 1 meter core, so 10 centimeter, some 6 samples we got it, 10, 15, etc. Some 5-6 centimeter as a last means. So you have calculated what is, that is the 96 centimeter divided by 100 centimeter into 100. If you do it, then that is called RQD. Anything if you get above 98% RQD, then only we can say that rock is a excellent rock or satisfactory rock. Otherwise, that rock is a very poor rock for any foundation construction. That is called your RQD. So, as I explained earlier, a thin wall sampler, a non-return wall. So that is inside wall friction. We are saying the cutting edge. Area ratio we discussed, inside clearance, outside clearance, like inside clearance, outside clearance we discussed it. Next is inside wall friction, non-return wall. So in order to explain that one, I am showing this graph sketch. Inside wall friction. Suppose if you have a frictionless wall surface inside, then smoothly the sample will start entering here. So that means the resistance offered by the tube against the flow of that soil into the tube will be less. Therefore, disturbance will also be less. So you can expect UDS sample, more precisely using UDS sample. Next is non-return wall. When a sample is moving here, air has to move in the upward direction. But at any point of time, air should not move in the downward direction. If air moves, sample will be crushed here. So for that purpose, we are using a ball chuck valve or a non-return valve. If you have this assembly in your sample collection tube, then you can expect a very good UDS sample. So I will repeat it once again. In order to get a UDS sample, 3 things are required. Clearance, it is area ratio. Inside clearance, outside clearance is one aspect. Internal wall friction should be 0 wall friction. Third one is a non-return valve or ball chuck valve should be fixed. So if the 3 things are satisfied, then you can expect a very good undisturbed sample. Otherwise, the sample is not at all undisturbed. Even though you are getting area ratio less than 10, but these 2 are failed, then you cannot possible to expect a UDS sample here, right? Fine. So next is it is called as the MCQ questions. So now, based on today's discussion, we have formulated some MCQ questions. I will read it one by one. You please answer. Undisturbed soil sample UDS. It may be defined as those in which the material has been subjected to a minimum disturbance. Here, option A is true, B is false. It is option A, true. Chunk sample is an example of disturbed sample. No, chunk sample is an example of undisturbed sample. Therefore, your option is B, false. Disturbed soil sample, the natural state of soil get modified partially or fully during sampling. It is true, fully. Option is B. Open pit collection is an example for disturbed sample. So it is true. Non-representative samples, those samples consist of mixture of materials from various soil, rock strata, or samples from which some mineral constituents has been lost. Non-representative, yes, it is true. Soil disturbance depending on cutting edge, yes, it is true. The sample disturbance depend only on inside wall friction, it is false. Sample disturbance depend only on non-return wall, it is false. Sample disturbance depending on cutting edge, inside wall friction, non-return wall, it is true. Area ratio less than 10 is called a UDS sample, it is true. These are all this list of references, textbooks we are used for preparing this module. I take this opportunity to thank Department of Collegiate and Technical Education and students for giving me an opportunity to deliver this particular lecture. Thank you, one and all.